what a blessing to have you here at Majestic Tutorials. Do you know that your academic success is guaranteed with us? Absolutely! You're set to perform excellently. Please help us grow and expand this young, vibrant channel by subscribing and sharing.
Welcome again. Here I'll be handling titration question and the endpoint, and also how to manipulate your table when you are when you don't want to do the experiment, of course. But please, science should be done and shouldn't be manipulated, because investigations requires the real thing. But in a situation when the environment is not conducive for you to do the analysis but supports manipulation, just like WAEC and NICO does, because Nigeria should be above the level of marking practical reports. Rather, they're supposed to mark the students immediately as they are doing the practical real life to know who added excess indicator and who added not enough and who added excess acid, who is not obeying the rules or taking the precautions, maybe leaving funnel while titrating. So these things are necessary while doing your titration. Okay, so at this point we will look at titration between, there are specifications given about this titration. Is between HCl and sodium hydroxide, but not just any HCl. So what's the strength of HCl needed? We are required to measure 8.5 cm cube of concentrated HCl to dissolve in what? Per 1000 cm cube of solution. But one thing that is very interesting here is that the strength, because when we say concentrated HCl, is kind of ambiguous. They were more specific. They told us about 36% weight by weight or weight by volume. 30% of that HCl. So for now, I'll give you the molarity. The molarity here is going to range from 0.098 to 0.1, if you like, mole per dm cube if you go and do this. So automatically this is our Ca, right? Then, but remember that this is labeled D, of course, as a sample D, because alternative A students have taken A, B, and C. Now the next one is D. So acid here is sample D. So if I may say this is CD, but if I say CD, somebody might get confused. That's constitution of the molarity of D. Then F is supposed to contain sodium hydroxide. That will be going to contain, is expected to, you are told to measure 6 grams of this in what? And dissolve in what? 6 grams dissolved in 1000 cm cube of what? Solution. Remember, not solvent, is solution, which is mixture of solute and solvent, which means you measure 6 grams and add it up to 1000, meaning this 1000 will collectively contain both the mass of solute and the solvent, okay, dissolved in 1000 cm cube of what? Solution. Now, what is the molarity, which we commonly know as Cb, but here it's supposed to be Cf, okay, to be specific. So the molarity here is that sodium hydroxide, first of all, we will find out that molarity, which is mole per dm cube, is equal to gram per dm cube all over gram per mole. Translating this, it means that molarity is equal to mass concentration all over molar mass. And molar mass of sodium hydroxide is 40. How do I get the 40? Sodium is 23, it will be given. So that means 23, which is here, plus oxygen is 16 and hydrogen is 1. If you sum this up, my dear, we're going to get 40 gram per mole. So the molar mass, the mass given now is 6 grams. That's the mass concentration. So which means, and we already know the molar mass, which is 40. So what's our molarity now? Remember, molarity is the same thing as mole per dm cube. Is now equal to 6 over 40. So from the calculator department, 6/40 0.15. Okay, so our CF or CB is 0.15 mole per dm cube. Maybe to obey significant, three significant, we can just say 50 again, 0.150 mole per dm cube. So I've just told you the molarities of the sample D and sample F. For people writing alternative B, remember, if you're writing alternative A, this is going to be your sample A and this is your sample B. Okay, so now this is automatically helping us to manipulate our endpoint. With this knowledge, I can now find my endpoint without doing the titration. How do I do that? And from that, I will teach you how to manipulate the table. So what is my CA over CD? Which one? Anyone you want to work with. I said here, you take anyone you like. Remember 0.098, I would want to work with that 0.098. Then our CB, which is the molarity of the sample F, is also 0.150. So we can now write the equation of the reaction, and from there we now get the theoretical endpoint. So the theoretical endpoint will now be, the equation of the reaction is HCl plus sodium hydroxide, of course, aqueous will give us sodium chloride plus water. This is aqueous and this is liquid. If you look at it, the equation is balanced such that the mole ratio of acid to base is 1. So 1:1. Now, using our formula that says CdVd, working with sample D, is equal to C what? FVF. It's the same thing as we know as CAVA, but because I want to rhyme with what they call this, equals ND over NF. So we already know our CD, which is 0. What? 0.098, CF 0.150, VF is the volume of the base, or we call it VB, whichever. Remember here, our VB, or here you can make VF, is your 25.00. If you use 25, if your school is using 25, but most of the school uses 25, we can use 25 or use 20. Okay, but we most times use 25. So these two possible values are the thing you're expected to use as your CB or your VB, that's volume of base. So we already know that. Here I want to use 25. All right. So the ND now is the mole ratio of the D, which is this acid. Mole ratio of this acid, which is 1. Mole ratio of this base, that's the F, which is also 1. So here is 1/1. The only thing unknown here is now my VD, and that's why I'm going to do my titration. So I will make subject of the formula. What's my VD now? My VD should now be equal to CF VF ND divided by CD NF. Substituting the values, what's my CF? 0.150 times, what's my VF? 25 is what I'm using here. ND here is 1. Then what's my CD? 0.098 times 1. So from the calculator department, what do we have here? What we have here is simply 0.15 times 25, 3.75, then divide by 0. So we're looking at something like 37. So 3.75 now divided by 0.098 is 38. Okay, we are looking at 38, probably 38 0.3. Remember, you have to put 0 here on the approximate. You can get, that means the range of our endpoint here, anybody that is getting 36 to 39, it should be accepted because of little variations. Remember, what the WAEC is marking, or the exam body, is how much you rhyme. But since they specified the molarity of the strength of the acid, they say HCl. So let me give the accurate thing. Please subscribe to this channel. Please subscribe to this young channel, Majestic Tutorials. I am here for your academic success. Remember, this channel is here to handle all the academic tutorials, both arts and science, while Her Majesty's World Science focuses on experiment and research and entertainment with science. You wouldn't avoid missing things like that at Her Majesty's World Science channel. I bet you enjoy that channel. But here is meant to help you pass the exam. We want to separate it. Anything tutorials should be here, then experiments should be there. So please help me grow. I'll give you the likely questions, how to manipulate the table here. And if I don't have time to solve all the likely questions, if you subscribe and follow here on this channel, we will get to more than 1,000 followers. We are close to that, of course. Right now we are 900, but you can help us get to 1,000 so that even before the exam, I can live stream the likely questions and other subsequent exams, both in mathematics, in English, your practicals, your theory questions. I'll get experts that will do that. So please help me grow this young channel. For you to visit this means your success is sure. Thank you for coming around. You won't regret. So let's be logical. Let us check the real molarity of 36% HCl. Okay, that will help us know the exact strength since we are manipulating. Okay, so check the value. Remember, the density is going to be 1.18 gram per cm cube, of course. So the expected molarity should be 11.65 moles per dm cube, of course. So when they say 36%, it means that 1,000 cm cube will automatically contain 11.65. So you ask yourself, 8.5 cm cube will contain X. So to find the accurate molarity, we now have all things being equal. Remember, he says volatile. That's why your endpoint is not too restricted. Our X should be now 8.5 times 11.65, or divided by 1,000, of course. 8.5 times 11.65 divided by 1,000. Okay, 0.99, 0.099. Okay, so the correct thing here, we just say 0.099. That is not bad. If we fix it here, we'll be getting 37, of course. So let's see, 3.75 divided by 0.099. 0.099. What do we have? As 3.75 divided by 0.099 is 37.8, which is still giving us 38 on the average. Now, having seen the range of the endpoint, the next thing is to teach you how to manipulate your table. Remember, your mark is determined by the teacher's report. If you vary with more than 0.1 from what the teacher recorded as the endpoint, you score 4/4 within 0.1. But if it is more than 0.1, you will score 3/4. Maybe if you vary with my own, like now I wrote 38.30 as your teacher, and you record your own as 38.40, you get 4/4. If you record your own as 38.45, you still get 4/4. But if you record your own as 38.50, you are now 2 cm, 0.2 away from what I recorded, you get 3/4. When you are 0.3 away from what I recorded, you get 2. When you are 0.4, meaning if somebody gets 38.70, the person will get 1/4. But if you are more than 0.4 away from the teacher's record, you have 0/5, meaning if somebody have 38.90 here or 80, the person automatically scores 0/4. So the manipulation of the table now depends on if the teacher is doing the wrong thing, meaning by diverging, by leaking the endpoint for you. But it shouldn't be that way. But in a situation whereby you want to manipulate your table, maybe you heard that the endpoint is 37.5 and you want to, that's, remember, 37.50, the rules on how to make your tables, which will give you the majority of the mark, is well explained at Sir Majesty's World Science channel. I've uploaded that video before now. So, but I'll still explain further here. All right. So, how to manipulate your titration table. Let's assume, I think I'm free to clean the equation or the reaction. So, to make table first, remember that your table should not, don't cancel your table. If you cancel your table, you will likely lose some huge mark, maybe 4, especially when you cancel to adjust to rhyme with that of the teacher. Don't cancel your table, which means try to be very accurate. So before you enter the hall, you might have already known what your table is all about. So over here is our burette readings. Here is the rough. Here is the first, second, and the third. It's better you make your table neat. So it's expected to write volume of pipettes used, which is 25.00 cm cube. Okay. Then here you write your final. Tell us that is in cm cube. And tell us your initial. Write initial. Also indicate the unit. And then volume of D used, because D will be in burette, because they'll tell you put D in burette, of course. And finally, volume of D used. Now, I want to manipulate my table to rhyme with 37.50 cm cube. Remember, if a teacher's endpoint is 37.50, any student can use 37.40, can use 37.60. Yeah, these three are allowed because they are still within. Maybe my teacher final average burette, titer value is 37.50, and that's what you record. Any student can decide to make his or her own, this 37.40 or 37.60. You still get your 4/4. And then, provided that you didn't cancel your table, you still get your 4 times 2. And if you have concordant titer values. So if you come to this place, take a number in your mind. I want my table to end in 37.40. See how I'm going to manipulate it. I will use the idea of, in the rough, add 0.8. Add 0.8 cm cube to the number in my mind. And the number in my mind is 37.4. So 37.4 plus 0.8 is automatically giving 38.2. So my rough, I propose to write 38.20. Here, 0.00, never you skip it, write it, so that when you minus 38.20, then the next one is that I will minus 0.1 from the number in my mind for the rough, and the number in my mind is 37.4. 37.4 minus 0.1 is 37.30. So here is 0.00. It will still give me the same thing. See, I've minus 0.1. In my second titer, I will add 0.1 to the same number in my mind. So what is that number? 37.4 plus 0.1 is 30 what now? 37.50. So here is 0.00, 37.50. Then I will write in my third titration, I'll write the number, the exact number in my mind. You see that? Which is now what? 37.40, 0.00, 37.40. If you now come to do your averaging, you say average volume of A used of D used, okay, you now be equal to, you tell they are all concordant because they do not vary with more. These two concordant, these two concordant. Concordant titers are titers that do not vary with more than 0.1, okay, or more than 0.2 on the maximum. If it is 0.3 difference, they are not concordant. Please don't use them. And the rule says if there is any two concordant titers in your table, you score 4 times 2, which should be 8 marks, okay. Sometimes other ones and your final averaging will have another mark. So remember that your practical chemistry is sectioned into 3 for now. They might change, but Africa hardly change. Sorry about that. First one is titration. Second one is the salt analysis. The third one is the random knowledge of chemistry. So that titration is usually the one with the highest mark, about 25 marks, while salt analysis is about 15 marks. Also watch videos here on salt analysis. They are all available for you, or you go to Some Majesty Easy World to enjoy more. Then the third one is likely 10 questions because practical is 50 marks, okay. So when you say this average volume of D used, you tell the examiner first plus second plus third, divide by 3, or you can go on by saying 37.30 plus 37.50. I'm using all of them because they all are concordant. Divide by 3. I bet you if you add this, add this, add this, and divide by 3, you will still get this number I want in my mind. So that's how to manipulate your titration table, okay. So let me check if this is still recording. Okay, so next is to see likely questions. This is how to manipulate your table, of course. Now the likely questions you can see there on the screen. Instead of using D and F, I was using A and B. No problem here, like I've corrected you, but in your exam you are advised to use D and F because that is the unit, that's the labeling, that shows you are not memorizing. But remember, if you use A instead of D, you are not, I don't think WAEC will penalize you. So it's still CAVA, it's just like a formula. You just know that A is now in the burette and B is in the pipette. So titration question, likely question 1 should be that A is 0.098 mole per cube HCl and B is a solution content.
Wait a minute. Have you heard about the Majestic table? It was designed and recommended by Some Majesty himself. Here it is. The amazing thing about the Majestic periodic table is that it provides a clear and colorful classification of elements from P block metals to metalloids to liquid metals. It also shows the boiling and melting points of all the elements. It also has the unique feeling of electrons in the shells of each element.